No, it's not enough. The fossil record proves change over time. Homologous structures prove descent with modification. And both of these occur in predictable biogeographical patterns. Evolution is fact. But what really drives it? Over time, genes move between otherwise isolated populations. This gene flow can create new species, yes, but it also results in reduced genetic variation. And over time, genes are lost anyway due to organisms dying before they can reproduce. Both of these mechanisms have an effect on evolution, yes, but they're not enough to explain it on their own. Something's missing. Arthur, could you fetch me my thinking cap?
Oof.
That's it. That's it. It's the individual. Individuals adapt to their environments and then pass those adaptations on to their offspring. Traits evolve through use and are lost through disuse. I've cracked the case. I need to tell Alika.
Jumbo Kirky.
Alika, I've done it. I've solved the mystery of evolution. This whole time, traits have been adapting through usage.
You know, Detective Lamar called earlier saying the exact same thing. We actually didn't choose to have long necks. If I could choose, I would have had a shorter neck because turtlenecks never cover my whole neck and it makes me very insecure.
But, no. Alika, what do you know about your family's history?
My grandma used to tell me this story. There used to be giraffes with all neck lengths, but over time the ones with short necks couldn't reach the tall leaves and they would starve. The giraffes with taller necks ended up thriving and would therefore have more kids and who would also have long necks. And so now all of us have long necks after many generations. Funnily enough, the trees had a similar story and grew taller since it was beneficial to escape being eaten. However, in response to that, the even longer necked giraffes lived longer and had more offspring, resulting in tall trees and tall giraffe necks. Grandma called that coevolution.
Gotta go, Alika. Someone's here. Thank you so much for the help. Genetic diversity. What could it mean? Genetic diversity. When there's a lot of genetic diversity, there would likely be a lot of different traits being expressed. Some traits would have higher fitness and some traits would have lower fitness. The organisms with the traits with higher fitness would survive and pass those genes on, while the organisms with lower fitness would not. This would select for certain traits, that's it. Natural selection for traits that confer fitness is the mechanism of evolution.
So, Detective, you figured it out.
Who are you? Are you the one who's been putting those notes under my door?
Who I am doesn't matter. What matters is geographic mosaic. Geographic mosaic is the theory of coevolution, where similar stressors are affecting the same species in various locations, and they are adapting similar adaptations despite living far away from each other. This is what is happening to the species the gallfly. They are developing new and aggressive traits. Climate change is changing our ecosystems, and we need your help, Detective.
Entomology nerd? I'm on the case.